All right, number 17. Now remember, number 17 is from Unit 9. What are Unit 9? What's the main focus? Matrices. Now, this is something I did not cover for you 2022, 2023 people, my originals. So it's just something I didn't cover. How to use matrices to find the area of a parallelogram defined by the vectors. Now, this is very related to this one. You'll have to look at the previous number 16. I did it once with numbers like 14, 15, 16, but then I put an addendum in there, how to do number 16 using matrices, a lot easier. So if you watch this, this will give you an understanding of what I'm doing here, or vice versa. Watch this one, then watch this one. But regardless, this problem is asking us to actually find the area of this parallelogram defined by those two vectors. A lot easier than you think. So I'm going to pick this to be x1, y1. I'm going to pick this to be x2, y2. And if we built a little 2 by 2, notice x1, x2, it's my x column, y1, y2. Now, so that's my y column. Now, a different student might have done things differently. They might have called this the 1, and this the 1, and this the 2, and this the 2. So they would have gone 2, -1, 5, 4. Now, let's talk about the similarities and the differences. So if I find the determinant of this 2 by 2, it's supposed to be giving me the area of this parallelogram. So we go -5, -8, -13. So we look at this and we're like, what the heck is that? Well, if we look at this one, 8 minus a -5, we get 13. Notice, that'd be like just fine. The area is 13 square units. So really, if you get a negative, it's just take the absolute value, you're going to get 13 square units. And that's it for number 17. All right, so here we go. Thank you, Lauren Kinsel, for bringing it to my attention that my original attempt on number 18 was full of error. So here we go. We got to know to solve the system of equations. We're trying to find x, y, and z. And here's our little formulas, assuming we're going to use Kramer for this, and that's what we're going to use. So we got to find the determinant in all three cases, which is d. So I'm going to do that first. So, but the first thing we need to do is rearrange these. So x equals 3y minus 3z plus 8. If I bring these over to the opposite side, I'm going to get that. Now if I do the same thing here, bringing these items over, I'd get -4x minus 5y plus z equals -14. This one's just sitting alone, but I'm going to insert a 0x plus 3y plus 2z equals +14. So I'm really focusing in those brackets. How do I find d? Well, d is the 3 by 3 matrix by just taking off all these coefficients. So 1, -3, 3, -4, -5, 1, 0, 3, 2. Get out our handy dandy calculator, and we're going to go to our matrices, and we're going to set one up. So I got to go to edit, because I want a 3 by 3, and it's already set up for 3 by 3, so let's put in the information that we need for this problem. So 1, enter, -3, enter, 3, enter, -4, -5, make sure that's a +1, and it is. That little smudge threw me for a little bit. All right, so there's a 1, and then 0, 2, 1. Now we need to find the determinant of this. So we're going to go to our calculator, we're going to quit, and then we're going to go back to our matrix option, go to math, because this is where we tell our calculator what to do with it. We want to find the determinant of that matrix. So we insert it. All we got to do is hit enter, and we get negative 43. All right. All right, some of you might have caught it, but I just double checked my work, and just like that, I made another little mistake. Where was it? Right there. I need a 3. And so there we go. And we need a 2 there. And now we're going to try our whole thing again. Second quit. Matrix. Math. 1. Want it. Alright. Matrix. And we want this one. Alright. That changes, that's a game changer. Negative 73. Alright. So, now that we've input our information correctly, we're going to move on. Now, what I'm going to do is I'm going to find y or z, because I noticed this last one is kind of inviting me to find y or z first, because if I can find z and plug it in, then I can just quickly find y, and then once I know y and z, I can plug it in here and find x. So I'm going to attack z, and we're going to go z equals dz over my d, which is negative 73, which is telling me we got to find that matrix. Now, how do we do that? We take the column defined by z, which is right here essentially, and we replace it with our constants. So I'm going to do that first. 8, negative 14, 14, and then everything else remains the same. Once I've got that, then I can plug that into my good old calculator. And so let's go. Let's go back to the matrix option. We're going to edit. We still want a 3 by 3, so that's good. And we want that 1, so let's hit enter. We want that negative 3, so let's hit enter. Now we want an 8. And we want that. We want that. We want a negative 14 now. We want that. We want that. Now we want 14. All right, so now we quit. And now we bring it back up so that we can find the determinant of that particular matrix and hit enter. And this gives us negative 292. So what's the formula? dz, negative 292, all over d, which is negative 73. So we're going to go divided by negative 73. And what do we get? We get z is 4. All right. Again, we could use Cramer's rule to find y. We could use Cramer's rule to find x. Same way we found z. But we're going to use our noggin. If z is 4, we're going to pop it in there. This is gone, so it's really 3y plus 2 times 4 equals 14. Now this is 8, so I'm going to subtract 8. So 3y equals 6. Divided by 3, we get y is 2. Now that we know that, we just keep climbing the ladder. We could use this one or this one. I'm going to use this one because it looks just a tiny bit easier. So that's x minus 3y plus 3z equals 8. Let's plug some stuff in. 3 times 2 is 6. So it's going to be minus 6. 3 times 4 is 12 equals 8. So we get x plus 6 equals 8. Subtract 6, we get x is 2. So our final answer is 2, 2, 4. And there you have it. Number 15. Did I say number 15? I meant number 18. There you go. If you like the video, like and subscribe. Thanks, guys.